Okay, circles. Lesson 10-2. Little reminder about what circles are. So as a circle is a set of points in the plane that are a fixed distance, the radius from a fixed point. So if we put a point on a piece of paper and draw or attach a string to it and go around it, then we'll get a perfect circle as long as that always stays the same. So they use, it says because all the points on a circle are the same distance from the center of the circle, you can use the distance formula to find the equation of a circle. Now I'm going to show you this, but you're never going to have to use it, okay? Because there's a much easier way to do it. Okay. So if we think about the distance formula, it says to write an equation of a circle with a center at -3, 4, and a radius of 6. So if we use the distance formula, we could put x and y in for x sub 2 and y sub 2. And for x sub 1 and y sub 1, we'll put the point -3, 4. And our distance in this case is going to be 6. So using the distance formula, remember we did this on Friday, okay? And you just worked with it again in the warm-up, that it would look like this. That our distance is a radius 6. We would put -3 in for x sub 1 and 4 in for y sub 1. And then if we have an equation like that, what should we do to simplify that equation? What would be the next thing? Square it, because we don't like the square root. We want to get rid of it. Okay. Now, like I said, you're not going to have to do this. All right? So you don't need to write this down. Okay. So if we squared it, we would get this right here. All right. And so that would be the equation for a circle. X plus 3, that quantity squared, plus the quantity y minus 4 squared equals 36. And that's using the distance formula. Okay? Well, there's a much easier way to do it than that. And we're going to look at that way of doing it. So notice, one thing to notice is that r squared and the center are visible in the equation of the circle. This leads to the general formula for a circle with a center at h, k, and the radius of r. So here is our equation for a circle. The center is the point hk. H is the x-coordinate, k is the y-coordinate, and the radius is r. And one of the things that we've done a lot of, we've used h and k a lot. We used it when we were doing parabolas back in chapter 5. As we talked about vertex, we used h and k. Okay? And we're going to use h and k in this chapter to represent the center of a circle, ellipse, a hyperbola, or vertex of a parabola. And so we're using them a lot. So they show us this example here. They say, okay, we got a circle that's centered at 5, -2. And they show it over here on the graph with a radius of 8. So they just replace the h with 5, the k with -2, and then put 8 in for r. And then simplify it. And there's your equation for your circle. So the equation for circle is really not that difficult to find. Right? It's just a matter of knowing the center and the radius. And on Friday, we found that if we know the endpoints of a diameter of a circle, we could find the center and the radius. And we're going to end up using that also. All right, so letter A says find the equation of a circle that's centered at the point 0, 6 and a radius of 1. So we need to identify h, k, and r. So what's h in this case? What would h be? 0. Okay, h is 0. And k would be 6. It's the y coordinate for the center. And the radius, they tell us, is 1. So then all I'm going to do then is take the equation for a circle here and plug in those numbers. So we have x minus 0, that quantity squared, plus y minus 6, that quantity squared, equals the radius squared. Then all we need to do is simplify that. So do I need 0 here? So I can just write it as x squared, yep. So x squared plus the quantity y minus 6 squared equals 1 squared, which is 1. And that would be our equation for a circle. Okay? It's as simple as that. So when they give you the center and radius, it's that easy. Okay? You don't need to use the distance formula. Just go ahead and plug them in. Now they give us a little helpful hint here. They say, okay, if the center of the circle is at the origin, then it just simplifies to x squared plus y squared equals r squared. Much easier. So letter B. They want us to write the equation of the circle with a center at negative 411 and contain the point 5, negative 1. All right? So once again, we need to find h, k, and r so we can write the equation of the circle. So do they give us any of that information? No? Or yes?
No.
Okay. Emily, do they give us any of that? What do they give us? Okay. So they tell us that the center is negative 411. So h is negative 4. K is 11. Do they tell us what r is? No, but they tell us where the center of the circle is, and they tell us a point on the outside of the circle. So how do I find the radius given that information? Yeah, the distance formula. We're going to find the distance between those 2 points. So our radius then is the distance between those 2 points. So we can use the distance formula if we want. So let's see, the distance from the x's. All right, that's all this means is what's the distance between the x's. How far is it from negative 4 to 5? Negative 4 to 5 is 9. So we have 9 squared. And one of the reasons I want you to think about this as distance is that what happens is sometimes you're going to end up with negative numbers, and some of you will not square them correctly, and you'll still get a negative. But the thing to remember is that no matter what I'm squaring here, it's going to be positive numbers. Okay? So how far is it from 11 to negative 1? 12. So we have the square root of 9 squared plus 12 squared. Let's see, that's 81 plus 144, which is square root of 225, which is what? 15, okay? All right. So our equation of our circle then. X minus negative 4 squared plus y minus 11 squared equals 15 squared. Put in h and k and r. So we get x plus 4 quantity squared, y minus 11 squared equals 225. So your final answer is going to have them simplified. So that would be your final answer then. All right, for this next example, we're actually going to look at the example in the book a little bit too. So if you're not there, turn to page 730 because that's where this is at, and you'll need it when we do the check it out. So the location of points in relation to a circle can be described by inequalities. The points inside the circle are the quantity x minus h squared plus y minus k squared is less than the radius squared. And the points on the outside are greater than the radius squared. And so we're going to look at some application problems using this. Raul and his friends are having a pizza party, and we'll decide where to have the party based on the delivery area of the restaurant. Suppose that the pizza restaurant is located at the point -1, 2, so they're right here at this red dot. Make it purple so we can see it. And the letters represents the homes of Raul and his friends. Yep, Raul. Raul. Whatever his name is. Use the equation of a circle to find the houses that are within a 3-mile radius, and we'll get free delivery. So here's what we can do is we can set up an inequality like we've done here that shows the pizza delivery area so Raul and his friends can get some pizza. So the center of the circle is at -1, 2, so they've got x plus 1, that quantity squared, plus y minus 2 quantity squared, is less than 3 squared. Now, one of the things you want to look at, first of all, is where are the obvious ones that it's the case? And the really only reason we need to use this inequality is for those that are questionable. So for instance, if I draw a circle here, right, we can see that B and D are definitely inside that circle, so they're going to get the delivery. But I'm not so sure about C. That looks pretty close here. And actually A looks pretty close also, and I need to check them. So there's actually two different ways we're going to look at. One is using the inequality, and another way is just using the Pythagorean theorem or distance formula. Okay? So let's talk about letter C, or where C is at for a second. Okay? C is at the point 0, -1. So we're going to use this inequality to see if C fits inside there. So since C is at 0, -1, I'll put 0 in for x and -1 in for y. And I want to see if this is going to be a true statement or not. Like I said, this is right in your book. Right? This part is. And so let's see, we get 1 squared here, which is what? 1 plus, and -3 squared is 9. Is that less than 9? No. 10 is not less than 9. So letter C is not inside the circle. Right? So that's more than 3 miles away. All right, you see how we did that then? Now the other thing we can do is we can actually use our right triangles. So since our point is at -1, 2, to get to A, I can think about it as making a right triangle. Okay. So if I use the Pythagorean theorem and I get greater than 3, okay, then I know it's outside the circle. So for instance here, if I, from -1, -2, if I go up 1, 2 here, so I'm going up 2 there, and I'm going over 3 here. So if I go up 2, that would be 2 squared, plus 3 squared. My question is that greater than, is that less than 3 squared? And obviously in this case it's not, so A would not be in there either. Okay? So my answer would just be B and D. Yes? I think it probably could be, but it says within the 3 miles. So yeah, if it was exactly 3, you would still say that was true also, okay? Okay, so here's my example for you. We're still using the same map. And it says, which homes are within 4 miles of a restaurant located at -1, 1? Now, you could do this a couple different ways. Like I like to draw the triangles. You don't have to do that, but you can. Is you could actually stick your piece of paper on top of the graph and trace it. Okay? Or like somebody suggested last hour, actually, we could use a piece of graph paper too, and you could just locate the points on there. So we have the point -1, 1, which is right here. And we want to be within 4 miles. So I'm going to draw my version of a circle here. So 1, 2, 3, 4. And go over 4. And down 4. And over 4. And then I'm going to make a very rough circle. Okay, there's my circle, right? Not the greatest, but not too bad. So I can see that obviously B, C, and D are inside there, right? But I'm not so sure about E. That might be in there. And A, I'm not sure about that one either. It might be in there. Oh, I can't tell for sure. So I'm actually going to either have to make triangles, or use the inequality. And so let's use the inequality first. Let's write that up. The inequality in this case would be x plus 1 quantity squared, okay, the opposite of -1, plus y minus 1. Okay? And we want that to be less than 4 squared, because it's within 4 miles. So let's try E, point E with that. So point E is at 1, -2. So I'm going to put 1 in for x and -2 in for y. And see if this produces a true statement. So I wrote the inequality using the center and the radius. Picked a point I'm not sure about, and I'm testing it. So we get 2 squared is what? 4, okay, plus -3 squared is 9. Is that less than 16? Yes, it is. So I can add E to my answer here. All right, since 4 plus 9 is less than 16, then E is definitely inside the circle. But since I'm not a very good drawer of circles, I can't tell if A is in there or not either. So I'm going to check A. I'm going to use triangles to do that one, though. So I'm going to go up here and over there. Okay. So we went up how far? How far did we go up? 3. Okay. 1, 2, 3. And went over 1, 2, 3 over. Okay. And so so this is for point A, 3 squared plus 3 squared, is that less than 4 squared? Is 9 plus 9 less than 16? No, okay? So 18 is not less than 16, so A is outside of the circle, and it's too far away. So my answer would be B, C, D, and E. Okay, does that make sense? Yeah. Thanks, Levi. Before we actually do example 4, we're going to do a little review here. Okay? Example 4 talks about finding tangent lines, and we're going to just do a little review of finding the equation of a line and talking about perpendicular lines. So if you remember from chapter 2, we talked about finding a line in slope-intercept form, y equals mx plus b. And we knew that m is our slope and b is the y-intercept. And then we talked about also using point-slope form to find the equation of a line. So if we know the slope of a line and we know a point on the line, we can use the point-slope form to find the equation of a line. Okay? And I've also written over here a reminder of the formula for slope. So we're going to go ahead and do, I'm going to do letter A here. Just one of the easier ones. So they give us a slope of -5, and they want us to find the equation of a line that goes through the point 1, 3. So I'm just going to review point-slope form with you. So I'm going to replace the y1, y sub 1, and x sub 1 with the 1 and the 3. So we'll have y minus 3 equals the slope, which is -5 times x minus 1. Okay? That's point-slope form. We use the point that we know, 1, 3, and the slope to find the equation of the line. So we will simplify the right side and then add 3. That's a point, using the point-slope form to get a line in slope-intercept form. Now, the only difference between A and B here is that with B, you would have to find the slope first of all. Okay, so just using the slope formula. We're not going to do that one. Okay. The other reminder is about perpendicular lines. What we learned about perpendicular lines is that the slopes of two lines that are perpendicular are the opposite reciprocals of each other, which means that we change the signs and we flip it over. Okay? So in other words, in this case here, if you look at these two lines that we have here, we have this line here is -3/2 x plus 4, and this one is positive 2/3 x minus 3. So their slopes are opposite signs. One's positive, one's negative, and then they're the reciprocal. What kind of angle do they form? Okay, a right angle. Perpendicular lines make a right angle, and that's why when you actually multiply the slopes together, you're going to get -1. Okay. So just a little reminder. Okay. So here I have, they want me to write the equation of the line in slope-intercept form that's perpendicular to y equals 5, 6x minus 7 through the point 0, -2. So they want to find the equation of the line that goes through here that is perpendicular to that. Okay, something close to that. So I'm going to use a point-slope form again because I know the point 0, -2. But what's the slope of the perpendicular line then? Okay, since the slope of this line is 5, 6, it will be -6 over 5. Okay. Opposite sign, change the signs, and flip it over, reciprocal. So we have y plus 2 equals -6/5 x. So y equals -6 over 5x minus 2. And that line, if I graph that line, should be, did this to me earlier. Let's try it again. Y equals -6 over 5x minus 2. There we go. And if I graph it, then it should be through 0, -2, and perpendicular. Okay. So we did that to talk about tangents. How many of you remember talk about tangents? Okay. Anybody? Okay. All right. Remember the words, but not the process. Okay. A tangent is a line that intersects something in one place. Okay? So a line that's tangent to a circle will intersect the circle only one place. If you recall from geometry, the tangent to a circle is perpendicular to the radius at the point of tangency also. So that's why we need to work with finding the equation of a line and perpendicular. Okay. So it's going to look something like this then. You have a circle here. Here's my radius of the circle, what we call the radius to the point of tangency. And then here's my line. So this blue line is perpendicular to the green segment there that represents the distance from the radius or from the center to that point. So to find this blue line, we have to go through the process here. So it says write the equation of the line tangent to this circle, x squared plus y squared equals 29 at the point 2, 5. And we're going to go through 3 steps to get there. Step 1, we want to identify the center and radius of the circle. Now, I have radius on there, but I mean, you don't have to recognize what it is or identify it, but it's not a bad thing either. So what's the center of this circle? Where's it at? Drew, where's the center? Well, what's the value of h here? Is there an h there? So the value of it would be 0. Okay? And what's the value of 8k? 0. Okay? So that means that the center of our circle is the origin. And our radius would be square root of 29, because it's x squared plus y squared equals the radius squared. Okay? So we find the center and the radius first of all. Okay? The next thing we want to do is we want to find the slope of the radius at the point of tangency. In other words, we want to find the slope of that line right there. Okay? From the center of the circle, which is at the origin, to the point 2, 5. Right, so we're going to use our formula for slope. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Change in y over change of x. Well, the nice thing is about the zeros, okay, is that I'll put them in here. They just equal 0. And we get y changes by 5, and x changes by 2. So we get 5 minus 0. 2 minus 0 is 5 halves. So that would be the equation, or the slope, for the line from the center to the point 2, 5. Okay, so that's step 2. Right? Step 1, find the center. Step 2, find the slope of the radius at the point of tangency. Okay. Step 3 then is just find the equation of the line in slope-intercept form. So we now want to find the equation of this line. Well, do we know what the slope of that line is? Okay. Do we know what the slope of this blue line is? Okay. It's negative 2 over 5. All right. It's the opposite reciprocal of the slope of the radius to the point of tangency. And we know a point. We know the point 2, 5. So I'll use the point slope formula to find the equation of the line. So once again, we find the center, find the slope of the radius at the point of tangency, use that to find the slope of the perpendicular line, which is opposite reciprocal, and then use point slope formula. So we have y minus 5 equals negative 2/5 times x minus 2. And then it's just a matter of solving for y. Now make sure of a couple things. One is your x has to go either even with the fraction bar or in the numerator. Okay. And then how do I add 4/5 and 5? Is it just, what does that equal? Does that equal 9/5? No. Okay. Okay. We need a common denominator, right? Okay. So a common denominator would give me 25 over 5 here. And 4 plus 25 is, so plus 29 over 5. You know your calculator will do that, right? Everybody take out your calculator just to verify this. So, to find the equation of the line that's tangent to a circle, find the center, find the slope. To find the line, we're going to do the slope as perpendicular, so opposite reciprocal, and then use the point slope formula to find the answer then. Okay?